Hi students, Class 9, Chapter-1, exercise number 1.2. See the question number 1. Find the cardinal number of the following sets. The cardinal number means the number of elements in a set. That is the cardinal elements. So, M is equal to, the set is given as P, Q, R, S, T, U. Right? Now, number of M is equal to, how many elements in that set? 1, 2, 3, 4, 5, 6. So, n of m is equal to 6. This is the cardinal number of the sets, right? And then second Roman number, then p is equal to x such that x is equal to 3n plus 2, n belongs to a whole number, and x less than 15. n belongs to a whole number and then less than 15. So, let me take it as P is the set x such that x is equal to 3n plus 2, n belongs to a whole number and x is less than 15. How many elements in the set we have to find out, right? First, the whole number means we know that is 0, 1, 2 up to less than 15 means up to the number 14, right? So, x is equal to 3n plus 2 is given. So, x is equal to, in the place of n, I am going to apply the value, right? 0, 1, 2, right? 3 into 0 plus 2 is equal to 3 into 0, 0 plus 2 is 2. Then x is equal to, when I apply the value n is equal to 1, this is n equal to 0, right? So, 3 into 1 plus 2 is equal to 3 1s are 3 plus 2 is 5. Then n is equal to 2, x is equal to 3 into 2 plus 2 is equal to 6 plus 2 is 8. And then n is equal to 3, x is equal to 3 3s are 9, 2s are 11. And then n is equal to 4, x is equal to 3 times of 4 plus 2, 3 4s are 12, 12 plus 2 is 14. So, the condition is the x value is less than 15. So, the p is equal to the number 2, 5, 8, 11, 14. Now, n of p, right? n of p, the number of elements in a p is equal to 1, 2, 3, 4, 5. So, this is the cardinal number of the sets, right? And then, see the question number, Roman number 3. Q is equal to y such that y is equal to 4 by 3n. y is equal to 4 by 3n, where n belongs to a natural number and n is greater than 2, less than or equal to 5, right? Now, we want to find out what is the number of q. Here n is the natural number and then small n is equal to, n is greater than 2 means 3, 4 and less than or equal to 5. So, n is equal to 3, 4, 5. So, here y is equal to 4 by 3n is the condition given. When n is equal to 3, what you get? Y is equal to 4 divided by 3 into 3 is equal to 4 by 9. And then n is equal to 4, y is equal to 4 by 4 into 4 is 4 by 16. Then n is equal to 5, y is equal to 4 divided by 4 into 5 is equal to 4 by 20. How many elements we have in Q? Only 3 elements. Then Q is equal to the set of 4 by 9, 4 by 16, 4 by 20. So, n of Q is equal to only 3 elements, right? If they are asking one more question means just count the number of elements. N is equal to 1 to 3 elements only, right? So, of course the sets will be only 3. The Roman number 4 is given as r is equal to x such that x is an integer, x belongs to integer, right? And x is greater than or equal to minus 5, less than 5. So, the x value is equal to greater than or equal to minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, less than 5 only. So, the x values are, these are the x values. Then r is equal to how many elements? Minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. then count the number of elements. N of R is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So N of R is equal to 10. See, Roman number 5 is given as the set of all leap years between 1882 and 1906. 1882 and 1906. In between that number means we have to find out what are the leap years. Leap years appears once in a 4 years, right? The first starting in between 1882 is given, right? And then 1906. In between, the word between means after that 1982 and before the 1902. After 1982 is 1986 is the leap year. Before means 1902 is the leap year, right? And then 1890. See, 1890, and then 1894, 1898, and then 1902. These are the leap years we have in between these 8 years. So the set S is equal to 1886, 1890, and then 1894, 1898, and 1902. How many sets? 1, 2, 3, 4, 5. So N of S is equal to 5 is the cardinal number. Now see the question number 2. Identify the following set as a finite or infinite. Which one is countable means we can say it is a finite. Which the sets are not countable or uncountable elements, we say it is a infinite set. First one, question number 2, Roman number 1. See the set of all districts in Tamil Nadu. In Tamil Nadu, can we count the districts 37 or 38? Yes, it is countable, right? Yes, it is finite. Or simply we can say it is a finite set, right? And second Roman number, the set of all straight line passing through a point. In a single point, how many straight lines can be drawn? Can you guess this? How many straight lines? It is infinite number of straight lines can be drawn in a single point. So that is infinite. We cannot be countable. It is infinite number. And then third Roman number, A is equal to X such that X belongs to Z and X is equal to, what are the elements? Less than 5. The X is integer, less than 5 is 4, 3, 2, 1, 0, minus 1, minus 2, it goes on. So clearly it is infinite set, right? And then fourth Roman number, B is equal, X is equal to X square minus 5X plus 6 equal to 0. X belongs to N. So clearly it is a factorization number. So clearly it is a factorization number. X square minus 5X plus 6 equal to 0. When we factorize this, we get minus 2 minus 3. So X is equal to natural number, which they say X is equal to a natural number. Here we get X minus 2 and X minus 3 equal to 0. Then X is equal to 2, X is equal to 3. Then the set B is equal to 2, 3 is the set. So it is countable. So it is a finite set. See question number 3. Which of the following sets are equivalent or unequal or equal set? Equivalent means number of elements in here, two sets are equal, we can say it is equivalent. Unequal means both the sets are not same. And then equal sets means both the sets are the exactly same element, then only we can say it is a equal set. So the set A is given as for Roman number 1. The set A is given as the set of vowels in the English alphabet, that is A, E, I, O, U. This is the vowels. And then the set B is given as the set of all letters in the word vowel, V, O, W, E, L. Right? Here the number of A is equal to 1, 2, 3, 4, 5. Here number of B is equal to 1, 2, 3, 4, 5. So the number of elements are equal. So it is equivalent set. Right? The number of elements are equal, so it is a equivalent set. See Roman number 2. C is equal to given as the set 2, 3, 4 and then 5. And then the day set is given as x belongs to a whole number and x is greater than 1 less than 5. Greater than 1 less than 5 means what are the elements greater than 1? That is 2, 3, 4, less than 5 only given, right? So we have to take up to the less than 5 number. So the set of n of C is equal to 1, 2, 3, 4. N of D is equal to 1, 2, 3. The number of elements are not equal, right? So it is not equivalent set. Then we have to go to the another condition, equal set or not. Equal set means 2 having 3, 4 is having, here 5 is missing, right? So it is not an equal set. So clearly it is a unequal set, right? See the third Roman number. The set x is given as x such that x is a letter in the word life. Only 4 letters, right? And then y is equal to the letter F-I-L-E, right? Let me take it as third Roman number, that x is equal to life, L-I-F-E. And then the set y is given as F-I-L-E. See, the number of x is equal to 4, the number of y is equal to 4, right? And then first conditions, both the sets are equal, it is equivalent set. And then see that the elements are appearing same, L-I-F-E. So here we have mentioned it is a equal set, not a equivalent set. Not only the number of elements and also the elements also same, so we can use the word it is a equal set, right? And then last Roman number, that is fourth Roman number, it is given G is equal to x such that x is a prime number and x is greater than 3 less than 23, right? And h is the divisor of 18. H is a divisor of 18. So the prime number greater than 3 is 5, 7 and then 11, 13 and then 17, 19 less than 23, right? So these are the numbers, prime numbers greater than 3 and less than 23. And then the number set h is given as the divisor of 18. 18 can be divided by 1, right? And then 2 and then 3 and then 6. 4 is not possible and then 5 is also not possible, 6 is possible and then 7 not possible, 8 also not possible, that is 9 is possible and then 18. These are the divisible of the number 18, that is 1, 2, 3, 6, 9, 18. Now n of g is equal to 1, 2, 3, 4, 5, 6. n of h is equal to 1, 2, 3, 4, 5, 6. So the number of elements in the two sets are equal. It is equivalent set, right? Thank you, students.